So hello everyone, today we are going to start with Solid Edge session number 26. In earlier lectures we have started with sheet metal and we have seen three commands there that were tab, multi-edge flange and flange. So today we are going to start with counter flange here. So to start with counter flange, I'll select the command. It is asking coincide plane, so we need to select the required plane for sketch. We'll hide the reference planes here. And next we are going to make one open profile so as to make a bracket here. I want this line to be applied with the relation of vertical. Then this vertical height I'll say 70 mm. Say auto scale dimensions and OK. This dimension will take here as 25 and this I'll say as 40 mm. Say close sketch, and when we say close sketch you can see here we have not applied any corner treatments, but it will by default take bending radius on these corners. So I'll say close sketch here. It will ask the direction of thickness. Next we need to extrude, and I'll say symmetric extent in this command so as to extrude it on both the sides. I'll take this extrusion as 45 here. Now this simple bracket is been made using counter flange command. You can see here at the corners bending radius are coming by default only. Bending radius are nothing but the inner side radius, this radius. This outside radius are not called as bending radius. So we can see here the bending radius size. I will say inspect, measure and click on this edge. So the bending radius is coming as radius 1 and so was the thickness. I will measure the thickness also here. The thickness also was 1 mm only. Suppose I want to increase the bending radius here. So I'll click on this counter flange, say edit definition, and in options I can change the bending radius value. So I'll put off this option and you can update the bending radius here. So in bending radius I'll say 2 mm as a bending radius. So it will get updated here. Say finish, measure and click on the edge. You can see the radius is updated to as radius 2. So in this way you can utilize the counter flange. Means whatever profile you are going to make, it will be converted into a flange, whether it is open profile or closed profile. We'll see the counter flange with one more example here. I'll say Control N. I'll take this new part, say isometric sheet metal, say OK. Here we need to make one tab first. We'll start with tab now. Hide the reference planes. Rectangle, center rectangle, smart dimension. Always provide the dimensions between two sides instead of directly clicking on the line. I'll say 200 mm. Horizontally and vertically I want this dimension to be taken as 120. Say close sketch. Here it will ask you thickness, so I'll say 2 mm here. So I want this thickness to be taken at upper side. I'll say at upper sides, finish and cancel. Next I'll say counter flange again, and it is asking you plane normal to curve. Earlier part this option was coincide plane, as we have not drawn any sketch, but this time we are having one tab here, so it is giving a different option here. It is asking plane normal to curve. So at whatever edge I want the counter flange to be made, I select that edge and I need to take one plane at any one corner. You can see plane is coming by default after selecting the edge. I just need to show the end at which side I want the plane. So I'll take this plane on the front side. As soon as I click here on the front side, the plane will be activated. And we need to draw one sketch here. So I'll take this open profile. We need to apply the height here. So I'll take this height as 60 mm. If I want to continue with the profile, I'll say this as horizontal next line. And then I'll say smart dimension again. We'll take this dimension as 22. So vertically I have taken 60 and horizontally I have taken the 22 dimension. So this 60 mm line will form vertical flange and this 22 mm line will form horizontal flange. Both flanges will come together with having the corner treatments as a mitre joint. That's why in some softwares like SolidWorks it is called as mitre flange also. Say close sketch, and you can see here the flange is taking place there after saying close sketch. So it will ask me about the depth of the flange. At whatever end I want the flange, I can put up the dimension here. So I'll put up the dimension here as 60 mm, and I need to show this on the other side. Here we don't have any support edge, so it is showing error. You can see the yellow mark, exclamatory mark coming in the screen. But if I flip the direction again towards the edge side, this flange is coming there. So the distance I require here is 60 mm and say enter. You can see here this counter flange has been made by using this two lines 60 and 22. Bending radius is automatically coming there. If I want to update the bending radius, I can go in options, and here I'll say bending radius as 1.5. This bending radius inner side has been updated here. Same for this bending radius also. Next, here we have taken the value for this extrusion. If I don't want this value, I want this flange to be taken as completely from one end to another. I'll say it edit definition again. Counter flange edit definition, and here we'll go for the end condition. As we can see here we are having three options, so I'll say end to end. So now we don't need to input any value there, it is taking from end to end this flange. Next one is chain. If I click on this chain option and if I click on the other edge, you can see all the edges are highlighted in orange color. Means this flange is coming as a chain on all over the edges. Same like as multi-edge flange only, but there was one drawback, we cannot treat the corner treatments there. Here we can edit the corner treatments also by going in options, we'll see it later. So you can see these joints are coming as mitre joints. I'll say it okay and finish. Now we don't have any gap here. You can see here these flanges are connected closely. A small gap is coming at corners only. Instead of that, we don't have any gaps. So if I want to provide any gaps here or open these flanges, so for corner treatments again I'll say counter flange, edit definition, go in options, and here you can see this radius is coming 1.5. It is also having one more option, one more tab here. Beside this general tab, we are having mitres and corners. So in mitres and corners, this mitre is coming off 45 degrees. Next, we have this finish end. I will not change it to mitre. If I want, I can change it, but I'll keep it rectangular only. Next, we are having gap option. So if I want to provide gap between the corners, I'll put up the value here. I'll say as 0.5 mm gap and say OK. So here you can see 0.5 mm gap is coming in. At all the corners this gap will be applied. Say finish and cancel. So now we are having mitre flanges with gaps here. So this was counter flange. So we have deleted the earlier flanges and now we are going to see counter flange by taking the direction of the horizontal flange inner sides. So for that I am going to make the sketch here. I will select the command first. Then select the reference edge. We'll go for the plane here. At whatever end we want, I'll take it in front side. Next we are going to draw the lines here. The first line will represent the vertical flange and the second line will be for horizontal flange. Earlier we have taken this flange on the outer sides. Now we are taking these flanges in the inner sides. Now I'll say this height as 60 mm and this direction I'll take as 22 again. So this is 60 mm from the bottom base side. Say close sketch. And now you can see this flange. I'll say up to the end. Now this flange is coming up to end. I just need to select any edge here. Then complete flanges are coming here, having mitre joints at inner sides. Earlier we have seen the mitre joints were at outer sides. This time these are coming at inner sides. I'll say OK here and finish. After finishing this flange, you can see here there is no gap given here. So if you want to fill the gap also again, we'll go for the edit definition option. Go for these options, and here you have this tab miter and corners. Here I'll select the gap as 0.2 mm, and this 0.2 mm gap will be followed on the miter flanges also here, on the horizontal flanges. Say finish and cancel. So this command is known as counter flange. So we'll go for the next command, that is going to be hem. Hem are of different types. We can see here there are total 5 types of hem given here. First one is flat hem, in which there is no gap between to this overlapping flanges. Second one is open hem, having one gap, that is the radius or diameter we can say. Then third one is this rolled hem. Fourth one is this teardrop shape hem, in which this inclined flange will always be connected to this flat flange. The other flange we are going to see here is rope hem flange. The names in Solid Edge are given a little bit differently. So we'll go through each flange one by one. So to start with, first I'll make the tab here. We need to make one base flange, then we are going to go for hemming. So to start with, I'll take this center rectangle here, put up the values, say close sketch, provide the thickness, I'll take it as 1 mm only at upper direction. Next, go for hem command. So in counter flange only, the last option is given as hem. So I'll select that command here, and we need to select the edge here for the reference of hem. So I'll select the left side edge here. We can see here one close hem has been created. And here this green line is shown as the sketch boundary, and the hem is coming within that boundary. It is because the material condition given here is material inside. So if I say material outside, this thickness of this hem will come outside the green line. So whatever condition is required, we can select that. Next, we are going to go for the options for different flanges in hem. So when you select this option, this box will appear here, and here we can see the type of hem is used as closed hem. That's why the display of this hem is coming without any gap. So if I want to change it, I'll say open hem, and we need to fill up this parameters here. So when it was closed, only one parameter was active here. You can see here this flange length was active. That was 7.5, means the distance of this straight flange, straight face from this edge to this edge was 7.5. Next we are going to say open flange, and in open flange this radius 1, means this bend radius is given here. It is coming as 0.5. I'll say it 2 mm here. Say OK. You can see here now this flange is coming as open hem, and this diameter of this curve is coming as 2, and the radius of this curve is coming as 2. We'll change the type of the hem now. Next we are going to see S-type flange. Here in open flange there were two parameters, that is bending radius and flange length. In this type there will be two radius. You can see here two bending radius. This is the first radius, and the smaller one is the third radius, and two flange lengths 2 and 4. So you can provide the dimensions according to your conditions. Say OK. You can see this flange is coming in its S shape. Next type will go for curl hem. In curl hem, same parameters will be there, but in this case, this one parameter, that is first radius, is bigger and the third radius is smaller, but the third radius will come inside the length of the first one. It will not take S shape. Instead, it will come inside after taking the first radius. So here you can see bending radius 1, that is given as 2 mm. Then the flange length number 2, 7.5. Bend radius 3 as 0.5. And this flange number 4, flange length number 4 is given as 7.5. So I'll say OK. So this is another type here given. After that we'll go for the next option, that is open loop. So in open loop, bend radius is given and one swap angle is given, that is 270 degrees. I'll say OK. Now this angle is coming till 270 degrees. So this was 0, 90, 180 and it will come till 270. If I want to change the angle, just go on the options and you can vary the angle. I'll say here as 180 only. Say OK. So you can see here this hem is coming till 180 degrees only now. The next option for the hem, that will be closed hem. So in close hem, this bending radius will come and this flange length will come here. That is 7.5. So this is the bending radius and this is the flange length. I'll say OK here. And now, as we have seen earlier also, it is also called as teardrop flange. In this teardrop flange, this inclined flange will always be closer to this flat flange. It will not change its angle. If I change the angle, even then also this inclined flange will be near to close of this flat flange. Say options, and if I say bending radius is coming as 2, I'll say as 0.5. You can see here, still this flange is coming connected to this flat face. So this is one of the most widely used flange type. So this is one of the most widely used hem type. The last one is centered loop. If you want to make hinges and brackets like hinges, then you can go for this option, that is centered loop. In this, it is having three parameters. First one is the bending radius, this first radius. Third one is again the bending radius, you can see here. And the last one, that is fifth one, is the angle. So this is the angle coming 270 degrees. If I say OK, then it will appear in this way. You can see here. So these are the different types of hem given in the solid edge. Say OK and finish. Cancel. Now if I want to make any cut here, we can directly go in this option, that is hole command. We can use the standard holes here. Suppose if I want to select this option and say countersunk, as the thickness is less, we can go for countersunks here most of the time. We need to screw the sheet metal parts, that's why. So if I take this size as M5 and fitment as normal, we just need to say OK and select the face for the positioning of the hole. I'll position it somewhere here. If I want to define the position, I'll take smart dimension, say as this vertical dimension and the horizontal dimension. Say close sketch and finish. You can see here this countersunk is coming. Next, if I want to make a normal cut or extrude cut, you can directly select the cut there. They are almost same only. So I'll say cut here, select the face and draw the required sketch to be cut. So I'll draw here one rectangle, say close sketch, put up the direction and say finish. So in this way you can cut the sheet metal parts here directly. Last option is given here as slot cut. So if I want to make a slot cut, I'll just select the face. So we need to make this center to center line for the slot. Provide the length for the line here. So I'll take this line for the length as 50 mm. Say auto scale on and OK. Now we need to place the slot position here. For that I'm going to select the point to point dimension solid edge. I'll say it as 20 mm here. And this position I'll take smart dimension again and say 60 mm. Say close sketch and here you can see the slot is coming. Now the width of this slot we can control it from these options. Here you can control the width of the slot. So I'll say it here as 6 mm slot. So I'll drag it on the downsides, click here and say finish. So this slot has been made. So in this hole command you can go for this hole, you can see here this normal cut and cut are same only, and lastly we have seen the slot command. So now we are going to make one simple part here. For that I'll say new part in sheet metal only, say OK. We'll start with the tab feature first. So I'll say center rectangle again, put up the values here. I'll take it as 100 mm and we'll go for this values now as 160. Say close sketch, we'll go for the thickness, I'll take it as 1 mm only, say finish and cancel. Next we'll go for the edge flanges. So I'll select this flange option, we'll draw one flange having the height as 50 mm, say finish, cancel. If you want to mirror this flange on the other side, You just need to select the feature and say mirror. You need to select the plane. For that I'm going to put on the reference plane, say OK and finish. I'll hide the reference planes now. Next we are going to go for counter flange here. So I'll select this counter flange, click on the edge, just click on the end point of the edge and you need to make one line. So I want this horizontal flange to come at the inner sides. Put up the value here for this flange. I'll say 6 mm. Say finish. And this 6 mm is coming from the outer side. Next we are going to go for this chain selection. Just need to click on the edge here. And this complete flange you can see here. This complete 3 edges are being made by the counter flange. Say OK. Say finish and cancel. If I want to change the width here, so I'll increase the width little bit. So I'll go for the edit sketch and we'll change the value here as 8 mm. Say close sketch. Say finish. Next, we want to mirror these features also now on the opposite side. For that, select this counter flange, say mirror. Put on the reference planes again. Select the mid plane so as to mirror the feature. Say finish. You can see here, this counter flanges are mirror on the other side also. Next, I want some flanges over here also. So for that, I'm going to select again flange command. Click on the flange and we just need to drag it here. So I'll drag it here till the distance of 12 mm. Say finish and cancel. I want to change this width condition, but I don't want this width condition from end to end. So I'll delete it again and again go for the flange feature and we just need to select the flange and then we'll go for the width condition as from end and I'll select this end here. So it will take the width from one side only, having offset distance from one end. So I'll change this offset distance. I'll say this as 20 mm only and this width I require is of 30 mm and I want to change this value here. I'll say it as 20 mm again. Say finish. Next I want this flange on the other side also. I'll say mirror. So for that I'm going to select the flange, say mirror, select the reference plane, say finish. Again I want both the flanges to be mirrored on the other side, opposite side. Select both the features here. Again go for the mirror, select the reference plane and say finish. Now if I want to apply the corner treatments, we have this option here, break corner. You just need to select the break corner. We'll go for the chamfers now. Click on this edges as a corners. It is taking 5 side. I'll say it 3 mm. We'll hide the planes here. And again we'll go for the break corners. Select break corner. Click on the required edges to be broken. I'll say 3 size only again. Say finish, cancel. On the other sides also, break. Select the required edges and say right click and finish. This vertical flanges also. So right click and finish. Next, if I want to apply the appearance here, I'll go on this view tab, go for part painter, select the body. I'll take this color as red, select the cabinet and say close. Now we need to cut the holes here. So for that, I'm going to say hole feature and I'm going to take simple holes here. So for that, select the type as drill hole. I'll take the size as 10 only, say OK. Select the face and here we'll take the center references for placing these holes. Same on the other sides. Lastly on this, say close sketch. Now I'll change the diameter here. I don't want it 10. It is coming little bit bigger. So I'll say it as 7 mm only. Say OK and finish. We want some more hole on these faces also. For that, again say hole. Select the type as drill only. This time I'll take the diameter a little bit smaller here. So I'll say 3 mm hole. Say OK and just need to select the reference face. We'll We'll place these 3 holes here. Go for the smart dimension. Select the reference as 8 mm and the other if distance from the vertical side, I'll take it as 3 mm. We'll say this dimension as 14 mm. Say close sketch. Again, we'll change the size. I want a little bit smaller holes, so I'll go for the size as 1.5 mm only. 1.8 I'll take here. Say it OK. And we need the end condition as through all. Say OK again. You can see here these holes are coming on the other side also, on this side. Say finish, cancel. Again we'll mirror this feature also here. So I'll select this hole, select the reference plane here, say mirror and say finish. If I want to make cutouts on this part also, if I want a slot cut, so I'll say this face for the sketch, or else I can directly select the command slot, click on the face, just go for the reference line, define the position of this line, define the width of the slot. I'll say 4 mm, say finish and cancel. We'll mirror the slot, say finish. Again we'll mirror the slot and this mirror tab on the other side. For that I'll select this plane here, say finish. So now at the mid edges I want to create hems here again. So for that select the hem feature, select the reference edge, and whatever type of hem you require, go for the options. I'll say it as open hem, say OK. And now whatever distance for the radius you require, you can put up here in the options. I'll say it as 0.75. Say OK and finish. On the other side also require hem, but we'll take this a little bit different type. So I'll select this hem, go for this edge, and here I'll say in options teardrop hem. For that I'm going to select this open loop hem, sorry, close loop hem. Here we need to give radius and flange length. Say OK again. I'll change the material condition. I'll take it material outside. So you can see here there was an error coming. It has been solved after putting up the condition as bend outside. Again I'll change the parameters here. I'll take this bend radius as 0.2 only. So it is taking a teardrop hem here. I'll change the parameter a little bit more here. I'll take it as 0.5 and finish. We'll change the appearance again. So I'll take it here steel, select the part and say finish, close. Now if I want to flatten this part, which is compulsory for us to flatten, we'll go on this tools tab, select the flatten, select the base reference face and select one edge referring as X direction. So you can see here. So this is the flatten view of the part. Again if I want to unflatten it, I'll say it ordered. It is unflattened. So this was the exercise we are going to make here. We'll continue with the other features of remaining sheet metal. So we'll stop here and continue in the next lecture. Till then, thank you.